In data science and artificial intelligence, we spend a lot of time handling data in files, or text in files in the case of natural language processing. A quote from Gemini, "Mastering file handling in code is a cornerstone of AI. Just like builders need a foundation for a house, AI systems rely on efficiently reading and writing data to files. This data, often in the form of text, images, or code itself, serves as the training material and output for AI models. By understanding how to work with files, you unlock the ability to feed data into your AI systems, capture their results, making them truly functional and adaptable." It's important to note that files can be either text or binary. Text files are often used for program code, HTML, XML, or other types of human-readable data. Binary files are typically used for images, videos, audio, and so forth. What happens when we open a binary file in a text editor? We see the binary code. This is not meant to be human readable, rather read by applications created to process binary files. In this example, I have an image file on the left, and on the right, I show the text result of opening this image file in a plain text editor. So it's important to note that all files are ultimately text, and in fact, even more ultimately, compiled down to ones and zeros for the computer to process. When you open a binary file in a text editor, you're going to see a lot of what looks like gibberish, but this is how the file is encoded, and this is the encoding for the file. A text file is a text file. It contains text that is intended to be human readable. Sometimes we apply special formatting to the text that tells applications how to display or otherwise handle it. We can also add known extensions to tell the operating system and other applications how to treat the file. So it is important to understand that that extension that we attach or append to a file name, everything following the final dot, for example, .py for Python files, or .txt for text files, .html for HTML files, .docx for word processing files, and so on. Those extensions are labels. Those labels are intended to tell the operating system or other applications how to process or otherwise handle the file. We can strip that label, remove it, and the file is still the same thing, but the operating system or application just doesn't know what to do with it now. But the content of the file is not determined by the label. We add the label, which is the extension, to tell applications like operating systems and other applications that can process files what kind of data to expect in that file and how to handle it. A text file might contain unformatted text. It might contain text that has markup. In this example, these are HTML markup tags. So I've put an H1 before the text, /H1, which is a closing HTML tag after the text. That tells a web browser that we should display this text in heading 1 format. Markdown, which is another markup language for text. If we put a hashtag in front of a string of text, that tells any application, such as a web browser or any other application that can render Markdown, that we want to display that text in the heading level 1 format. So text is text, and we can use different languages to write our text that different applications can understand, or we can use markup languages to mark up our text and determine how to tell applications how it should determine how to display that text. When we look at data files that represent rows and columns of values, these are primarily stored and transferred as comma-separated values, or CSV files. These have the extension CSV, standing for comma-separated value. In this example, on the left, we see a CSV file which is simply text that has rows, and each row is a comma-separated list of text. You'll notice there are no spaces here because a space is actually a text character, and in this case we don't want to represent a space before our data points. So these are our data points, and our data points can be strings, they can be dates, as in this example, they can be numbers. Here we have a floating point number. And if we open a CSV file in an application that can process CSV files like a spreadsheet, we get something that might look like the image on the right. This is using the Mac Numbers application. And Microsoft Excel would be the other commonly used spreadsheet, or maybe you have Google Drive and you're using word processing and spreadsheet applications there. But spreadsheet applications can always read CSV files and they can write to CSV files. So you'll notice that the comma-separated values give us the data and the data only. There's no formatting applied. So if you have a specific formatting, you see over the image on the right, we've got some background highlighting for the first row and the first column. When we save this to CSV, none of that is captured, none of that is saved. CSV files are for transporting data that is in tabular format. And it is the most common way to save and transfer data. When you're working with programming languages, you never want to have to read a file that was created in a application like a spreadsheet application, because different spreadsheet applications are going to handle the file differently. When we looked at the binary encoding for this image file, this is the kind of thing that you can expect when you open a file from a different spreadsheet application as a plain text file. You're going to see a lot of gibberish, which is the proprietary encoding for that application. We never want to have to deal with that when we're working with programming languages. What we would like is to just work with the data alone, because the data is really the only thing that we care about when we're reading in and processing data. We just want the data itself. So CSV files are the common way to do that. You may have also come across files where instead of values being comma separated, those values are separated by tabs. Tab is a special character that is a non-printable character. And I have often seen, unfortunately, a lot of tab-separated value files with the .csv extension, which can be misleading because tab-separated values are not the same as comma-separated values. You can actually, if you have tab-separated data, you can use the .tsv extension for tab-separated values. You can and should, because that tells any developer or any code that is reading in that file that it should be treated as tab-separated values versus comma-separated values. When we store files in the cloud, they may be accessed via a variety of methods. We can access these via APIs or command line tools. Local files are accessed using program libraries. And in this code segment for Python, we list the files in the current directory, manipulate a text file, and manipulate an image file. So this is an example of file processing in Python, where the first example uses the OS or operating system library in Python, and then the command os list directory to list all the files in that directory, and then a for loop to iterate all the file names that is returned by os.list directory, and then print those file names. In the second example code snippet, we have a file called quotes.csv where we're reading in stock quotes. So we can open this file for reading in Python, and we can use a Python command, readlines, which will read the file line by line. And then we can access the file as we would any list. We can access the different lines in the list. And we can open another file for writing. So we open the file for reading with an R, which is the default. We could have excluded the R there. We open a file for writing with a W. And we can write to the file. So in this example, what I have done is opened the file and taken the first row and changed all of the text in the first row to uppercase and then wrote the file back. And then in the next code snippet, I open that modified file that I just created and print the first few rows to just confirm that the modified file indeed has the first row in uppercase. And the final code snippet here just gives you an example for manipulating an image file with the Pillow library. So the Pillow library is a commonly used library in Python to manipulate image type files. So from PIL, I can import image, and then I can use the image class to open a file, vision.ping. And in this case, my file vision.ping is in fact this image that you see up here. So if you want to run this code, you can right click on this, save image as, and then just save it as vision.ping. And then you can use that image file along with this Python code. And this Python code uses the image library to simply resize the image and then rotate it 180 degrees, which is going to turn it upside down, and then saves it to a new output file. The next code sample uses the quotes.csv file. If you want to run this code sample, you can simply copy and paste this data here, copy it, paste it to your favorite text editor, and save it as quotes.csv. And you can use that to run this next example script where we're doing some manipulation of a CSV file. So we import CSV, which is a Python library. We import requests, which allows us to get web pages. And I'm importing Beautiful Soup, which allows us to parse web pages. So we're demonstrating a couple of different techniques here for handling files with Python. I have used AWS Secrets to store a secret key of mine. You can replace this with your own API key because we're going to use an API here to get some additional quote data. Optionally, if you want to run this code using real-time data from the web, this get quote function does require that you have an API key. So I store my API keys in Secrets Manager in AWS. So if you have your code stored in Secrets Manager or your key stored in AWS Secrets Manager, this code will allow you to access your key this way with your secret ID. But if you have another way that you want to access your secret key, then you can just replace the contents of this function to access your secret key however you'd like to. Sometimes folks like to store their secret keys and passwords in environment variables. Maybe you have another online encrypted place that you store keys. Maybe you store them in the keychain in Mac or something else. I never recommend putting hard-coded keys into code, but I will admit that I do that sometimes to just try something very quickly, but then I'm very careful to never commit that code to an online repo, be it public or private. If you ever hard code any kind of key or secret into a file to quickly test something, you should immediately then remove it from the file so you don't accidentally end up committing it somewhere where that key might be compromised. So that's why I choose to use Secrets Manager. So here I've used Secrets Manager to get my key, to utilize this get quote method. So if you would like to run that method, you can go to alphavantage.com, which allows you to get some live real-time quotes, which is how I got the quotes, the stock quotes that you see up above. or you can simply use those quotes that I've already given you in the CSV file. There's another example here that shows you how you can web scrape, and I have a warning here to be aware of potential terms of service violations when web scraping. In general, most websites will have a policy in their terms of service and terms of use that says that you cannot scrape from their website. But I provided an example here for when you find a website that does allow scraping, and if you wanted to scrape some data from that site. And this function uses web scraping to get the top NASDAQ 100 symbols that we can then use the other function to download data. And then the main function that actually pulls the data and downloads it given those keys. So this script shows you how I created or how I downloaded this data. So if you wanted to get your own real-time or at least more recent stock data to play with, I've included the script of how you can do that. But if you just wanted to practice with reading in CSV files, like I said, you can just copy this data and save it as a CSV file for your practice. And that is all we have on this site. This is just to give you some code snippets that you can use as you're learning to read and write from data files using Python.